The relationship between Ka and Kb. For conjugate acid-base pair, Ka and Kb are related in a special way. Let's start by writing the ionization equations for the following. The reaction of ammonia in water to produce ammonium and hydroxide ion, and the reaction of ammonium in water to produce ammonia and the hydronium ion. Let's see now, because NH3 and NH4 plus are a conjugate acid-base pair, if we can't see this relationship between their Ka and Kb expressions. So let's start by writing the equilibrium expressions for each equation. So starting with Kb, which is related to the base dissociation, we get NH4 plus concentration times OH minus concentration over the concentration of NH3. And Ka is concentration of NH3 times concentration of H3O plus over the concentration of NH4. Again, here's Kb with its dissociation equation and Ka with its dissociation equation. What do these expressions, Ka and Kb, have in common? Both dissociation constants have NH4 plus and NH3, but in one case in the denominator and in the other the numerator. Multiply the two constants together, multiply Kb times Ka, and those terms cancel out. So the NH4 cancels, so does the NH3. And we're left with hydroxide ion concentration times hydronium ion concentration. And that's a special value known as Kw, or K water. The product of Ka and Kb for any conjugate acid-base pair yields the ion product constant Kw. For a specific conjugate acid-base pair, Ka and Kb are related. In this way, the product of Ka and Kb is equal to Kw. Therefore, if you know the value of one of them, you can calculate the other. Example 9, calculating Kb from Ka. Ka for an acid, Ha, is 2.0 times 10 to the minus 7. What is Kb for its conjugate base, A minus? Use the given Ka to calculate Kb for the conjugate base. Know the dissociation equation for the acid and its conjugate. Here's the acid dissociation and the generic base dissociation. Identifying these two dissociations helps in an open-ended question where it may be required, though not asked explicitly in the question. We know that for a specific conjugate acid-base pair, the relationship between Ka and Kb is given by Kw equals Ka times Kb, which means that Kb is the constant Kw, 1 times 10 to the minus 14, divided by Ka, 2.0 times 10 to the minus 7, giving us a Kb value of 5.0 times 10 to the minus 8.